Hi everyone, my name is Clara and in a couple of months I will be becoming a doctor. I created this YouTube channel to talk about things that I feel are important, and that's why today we will be talking about fat physiology. We will be answering the following questions. How does fat get burnt? And what is the science behind fat? We will attempt to answer these questions as research-based and rigorously as possible. And of course, let's have some fun. So, fat is found all over the body, and there are two major types. We have visceral fat and subcutaneous fat. Visceral refers to any organ of the body. Thus, visceral fat refers to the type of fat that surrounds the internal organs. And of course, sub meaning under, and cutaneous meaning skin. Thus, subcutaneous fat refers to the one that is under the skin. Furthermore, fat distribution is influenced by age, sex, endocrine determinants such as growth hormone, cortisol, and sex steroids, etc. Now let's zoom in and see a little bit more closely our fat tissue. We can observe the three primary layers of the skin, which are the epidermis, the dermis, and the hypodermis. Epi meaning above, dermos meaning skin, and hypo meaning under. Additionally, hypodermis is another name for the subcutaneous fat, which we mentioned previously. Now, a little bit more zoom. Let's see a little bit more closely our fat cells. So fat, oils, butter, is primarily stored in fat tissue. And the appropriate term for fat tissue is adipose tissue, which is composed of adipocytes, where adipo means fat and cyte means cell. And these cells are responsible for storing energy in our body. This energy is stored inside these adipocytes mostly in the forms of triglycerides, where tri refers to the three fatty acids and glyceride refers to the glycerol, gripping the three fatty acids. So it's the backbone that carries the luggage. But unlike this dude, glycerol can only carry 3 bags. By the way, triglycerides are types of lipids, which also mean fat. And while adipocyte comes from Latin, lipo comes from Greek, but mean the same thing, fat. So now that we discussed energy storage, now let's talk about adipocyte size and how you lose it. So depending on the average group of the subject, the average size of the adipocyte can be determined. So the size in a human fetus is on average 45 micrometers. The size in a human baby is on average 110 micrometers. And the size in a normal human adult is on average 125. Although I'd like to clarify, I don't mean to offend anyone saying normal adult. I'm talking about the statistical definition of normal, associated with body mass index, perfectly represented in the Gauss graph of normal distribution. So with that out of the way, let's continue. Lastly, in obese adults, fat cells are 180 micrometers on average, so comparatively larger. And for the real reference, here you can observe clearly the variety of size of fat cells between fetal versus adult. Now, let's talk about how do you actually manage to make your fat cells bigger, which is through adipocyte hypertrophy. So we know that adipocyte means fat cell, while hyper means a lot or more, and trophy means nourishment. where hypertrophy ultimately means the enlargement of a tissue from the increase in size of its cells. And we usually associate the word hypertrophy with muscle building and enlargement. But it can happen to any kind of tissue, in this case, fat cells. So, adipose tissue expansion in obesity can occur through increased lipid loading into existing adipocytes, leading to increased cell size or adipocyte hypertrophy. So, what does that mean? It means that fat tissue can increase in size, especially in obesity. And it does so by fat loading into our fat cells. So, until now, we have discussed fat distribution, the 3 layers of the skin, adipocyte hypertrophy, and fat loading. So, let's now talk about the last part of today's video.
Burn fat.
Wow. First of all, you don't burn it, unless you're the Ghost Rider, the Fire Lord, or the Human Torch. So, if we don't burn fat, then how does it get eliminated? Well, remember we talked about adipocyte hypertrophy? Well, if you can make it bigger, you can definitely make it smaller. And I'm talking about adipocytes. So now, let's see how you can get rid of the fat inside our fat cells. The process of which I'm talking about is called lipolysis, where lipo means fat and lysis means breakdown. The main stimuli for fat breakdown is low blood glucose levels. Now, let's see what triggers specifically the breakdown of fat. The most potent molecules that trigger fat breakdown are adrenaline, noradrenaline, glucocorticoids such as cortisol, and T3 and T4, which are big power boosts, which technically it's called synergists, for adrenaline and noradrenaline. Other not so potent molecules are the following. So, now that we have a molecule triggering our fat breakdown, we finally started. So, first of all, this is the lipid droplet where all the fat is stored. We will have several molecules attached to the droplet surface, perilipin and CGI58, for starters, which when inactivated are attached together in a bond. Now that they're activated, they will unattach. Perilipin will attach to hormone-sensitive lipase, and CGI58 will attach to adipose triglyceride lipase. They'll all work as a team to break down the little pieces of fat storages. Lastly, monoglycerol lipase will cut the final bond. Now, the resulting molecules are 3 fatty acids and the 1 glycerol. So now that we chopped up our triglyceride, its pieces have different places to go to provide energy. The liver, the muscles, the kidneys, or it can even stay. Glycerol can travel to the kidneys or the liver to make us some sweet, sweet glucose through gluconeogenesis. And now about how we actually lose fat and an introduction about ketogenesis. We will have 2 pathways of fatty acid breakdown: beta oxidation and ketogenesis. Beta oxidation is the primary pathway for breakdown of fatty acids, which take place in the mitochondria, in liver, muscle, and fat tissue. Oxidation meaning the change of a chemical substance because of the addition of oxygen. And beta because there's where the fatty acids are going to be cut from. While Genesis means creation, and keto means sour? Well, that came out of nowhere. I'm kidding. That's the origin of the word, but it really means a molecule with a carbonyl group. And due to the majority of the molecules with a carbonyl group tending to be acidic, I'd assume that's why the origin of the word keto means sour. As we mentioned previously, beta oxidation is a primary pathway for breakdown of fatty acids, while ketogenesis is triggered in extreme conditions, such as prolonged starvation, intermittent fasting, the keto diet, or any diet that actively avoids carbohydrates in large percentages, diabetic ketoacidosis, uncontrolled diabetes mellitus 1 more prominently, etc. And we finally finished! So, today we learned about the metabolism and physiology of fat tissue and why it's so important. By the way, before you go, I would very much appreciate if you would help me gather some funds so I can start my own clinical/science research. So hopefully you can subscribe, comment, donate to Patreon or PayPal. Also, I provide medical English tutoring for medical professionals whose primary language is not English. So, we can roleplay clinical cases, improve your spoken English in clinical settings, or if you want to share your published paper or practice how you explain your clinical case or research in a conference.